Hi girls, in this video we're going to be looking at how ionic bonds form. Now, all substances are made up of either atoms, molecules or ions. And the way these particles are arranged in a substance is described as the structure of the substance. And the structure of the substance depends on the nature of the particles present, are they atoms, molecules or ions, and the actual forces holding them together. A chemical bond is held together by an attractive force, and these occur between atoms, ions or molecules, and in all of these you have to find that attractive force. Now that attractive force is always an electrostatic force, so it's always between positives and negatives. Now there are three types of primary bonds. They are metallic bonds, which are found in metals, ionic bonds, which are found in ionic compounds, and covalent bonds, which are found in molecules and covalent networks. When looking at how a bond forms, you have to go back to the atomic structure. In this example, we're going to look at sodium chloride. So metals have a relatively large atomic radii. So remember, atomic radii is defined as the distance between the nucleus and the boundary of the electron cloud. So sodium, for example, has got an atomic structure of 2, 8. Remember to always keep your electrons in pairs. 1. So, it does not have a strong electrostatic attraction for its outer shell electron. Remember, the attraction for its electrons is dependent on both charge and distance. So in this case, even though there are 11 protons, 10 of those protons are being shielded by complete inner shells. So the effective nuclear charge is only 1. So the attraction between the nucleus and this outer shell electron is not very strong. Now, metals which have few valence electrons don't tend to have a strong attraction for their outer shell electrons. So it becomes very easy for sodium to lose that electron. So you can see here that sodium has lost that electron. It now becomes a sodium ion because it has got 11 protons and only 10 electrons. And you'll notice it now has a stable electron configuration. Now, nonmetals have a small atomic radius, and the reason that they have a small atomic radius is because they have a high nuclear charge and therefore have a strong attractive force between the nucleus and their outer shell electrons. So if you look at chlorine atom, it's got an electron configuration of 2, 8, 7. It would have a smaller atomic radius than sodium, even though they both have their outer shell electrons in the third shell, because there is a stronger attractive force between the nucleus and its outer shell electrons. Now, because of this, it has a high electronegativity. Now remember, electronegativity is defined as your ability to attract an electron within a bond. So it's not talking about trying to attract its own electrons. It's talking about trying to attract another atom's electrons. So the higher the electronegativity, the stronger the attraction. Now, in this particular case, because chlorine has a high electronegativity, it attracts an electron from another species quite strongly. This results in the formation of a chloride ion, which is 2, 8, 8. So it's now an ion because it's now got 17 protons, but it's now got 18 electrons. So an ionic bond is formed when a metal transfers its valence electrons to a non-metal. So the metal then forms a cation, and the way to remember this is cation has a big plus sign in it. Okay, or here's another one, the cat positive ion. So the pussycat went, it's got a positive ion, and a non-metal forms an anion. And the way to remember this is a negative ion. So what this picture is showing here is that the sodium atom, which had 11 protons and 11 electrons, transfers its outer shell electron to the chlorine. And the sodium ion now forms a positive ion, which has got a stable electron configuration. And the chloride ion chlorine has now gained an electron to form a chloride ion, and once again you'll notice it's got a stable electron configuration. So the ionic bond is the electrostatic attraction between the positive ion and the negative ion. Remember, the positive ion is called a cation. The cats went positive, or look for the plus sign, and a negative ion, a negative ion, is an anion. So this diagram is showing what the ionic bond looks like. What you have is you have a negative ion surrounded by positives, or you have a positive ion surrounded by negatives. And it's non-directional. Each negative is attracted to every other positive, and each positive is attracted to every other negative. So it's an electrostatic attraction between positive and negative ions, and we had a complete transfer of electrons.